Let's go. There we go. All right, we are live, live and in living color, live and in living color. There we go. So let's get this rolling. Make sure we're good. So I hope everybody is doing good. Let me make sure sound is rolling and all that kind of good stuff. Hi everybody. Hello. How's it going? How's it going? Let me do what I did the other parts here. Put my email in the chat. Okay. I want to put that in the chat. Whether you're live with me or on demand, um, going through this for somehow, that is my email that I put up here. That I put up here with this. If you have any questions about anything going forward with anything, or you just like I said, you want to, they said you want to, feel free, please, to reach out. That is my email. Please, I'm more than happy to. He said more than happy to help out with anything there. So please, please reach out with an email. Okay, I'm more than happy to answer questions of that sort too. So, what I'm going to talk about there. What's up? What's up, Raquel? How are you doing? So again, I just want to put a big focus, put a big focus on this right here. Like I said, just because this might be the last day of my live streams with this doesn't mean I'm not available. I said, please, like I said, like I said, reach out if you have questions of any sort. I'd be more than happy to help out. Okay, reach out with you. I said just to make sure things are going. I hope everybody's doing good. But yes, what I'm going to go through in this instance is I'm going to go through, if I can bring this up, is I'm going to be going through topic 4 of these packets, of the packet here. Topic 4 was dealing with what we like to call, what I was calling bivariate data, which is just an interesting and crazy term for just saying two different types of data. You're comparing two different data points. I'm comparing apples to oranges, or I'm comparing, you know, as time goes on, I'm doing this. What's up, Brandon? What's up, Brianna? So, there we go. So we're good on that. So, again, topic number 4, which is just dealing with, which is just dealing with what we remember talking about scatter plots. Yes, fun stuff. Scatter plots, I know. Fun stuff. Scatter plots. Pretty simply, if I talk, like I said in the last couple classes with this, that if you look at the quick review on the left, it's going to sit there and it's going to tell you basically the vocab of everything. Anytime with all of these, this tells you all of the vocab on this. So the vocab helps to explain the example that should hopefully help you get to the practice to be able to do this. Okay. So what I hope on is this isn't too this isn't too much of a thing here. But so if I look at this and it says the table shows the distance in miles and price of airfare in dollars. So let's look at the example first. The example says the table shows the temperature and a number of tickets sold at a movie theater. You're constructing a scatter plot of the data. It says, is there a relationship? So the key with the scatter plot is you're trying to find out, is there a relationship between temperature and the number of tickets sold? So in our little example here, we're trying to find, is there a relationship between temperature and the number of tickets sold? So what they did in the example here what they did in the example is they created the scatter plot. And in that instance, zoom that to where, so like our first data point, a temperature of 40, they go over to 40, and then it's up to 120. I'm over to 45, and then I'm up to 100. I'm over to 50, and I'm up to 125. And if you remember during class, this was kind of like a, I think we did the Monopoly. It was like the Monopoly pieces on the board and how the Monopoly pieces compared with the price. we're talking about the price of the monopoly, like the boardwalk and St. James Place and all that kind of good stuff, and how the is there a relationship between how far away they are from go to how far up the price is? I remember that's what we were doing on there. So, anyways, let's do this here. So, if I construct this scatter plot in this instance, I'm going to kind of go quick, but if I go, so if I construct this scatter plot and I'm going, zoom it actually in. So if the first data point, I go over to 200 and then I go up to 250. I go up to 250. If I go over to 250, which is halfway between 2 and 3 there, I go up to 300. And I'm just going to kind of continue to continue to place these. I'm going over to 3, up to 275, right about there. Okay, over to 350, and then up to 150. I hope this is making kind of somewhat sense. Okay, try to get the remainder of this here, and all I'm doing is just coming down coming down the table that's above right here. Okay, between 5 and 6. Okay, one that's up. So there, right. So what you see right there is the scatter point of the scatter points, the scatter plot that was created by comparing what was the distance. So the distance compared with, I believe it was the price. So distance and price. And what you're trying to find out is there a relationship with the amount of distance that's traveled compared with the price that's paid? So when you look at this scatter plot now, so when you look at this scatter plot, is there some kind of a correlation? Is there some kind of a, is there some kind of a trend line? Is there something that's, is there a trend line? Do the dots generally go this way? Do the dots generally go this way? Is there some kind of a trend? And if you look at this, look at our dots that we have right here, the big answer on this is just one big old no. There's no gaps. There's no outliers. The outliers, ones that are like way out here. You don't have a cluster of points that are like together. Okay, I mean that's kind of making sense there. But in this instance, with the scatter plot that we made, there's no association with anything on this. So so when it looks at this and you say, well, there's not appear to be any clusters, gaps, or outliers. Okay, there's no pattern in the data, so there's no relationship between distance and price. Here's your price, here's all your data points. There's no relationship between those. That makes sense. Okay, talked about that again with that monopoly one there. We were talking about the distance away from distance away from go. Is there a difference between the distance from, or is there a relationship between the distance from go and the price you pay for the piece? Okay. So we look at 4.2 and talk about any type of linear associations. So you talk about the association between data in a scatter plot can be either linear or non-linear. So we thought the whole point about this is dealing with what we call trend lines, and what I was just talking about that above with 4.1. I was just talking about that above with 4.1 there. So above, could I have drawn a trend line with anything on that? And the answer to that was no, because the points were all over. So the trend line, again, it tells you here's a line on a scatter plot drawn near the points, which approximates the association between paired data. Keyword: paired data, paired data, paired data. If the data are linear, the association can be positive or negative and strong or weak. So in this instance, in the example, you see that the points, I can draw a line in between, and the points are generally around that line. So you can sit there and say it's a positive, strong value. So it is the association is positive, it's linear, and it's strong. Now, in number one on this, in number one, you have your dots that are looks to me that they are going down this way. Okay. Now the question is are those points generally close to that association? I personally don't think so on that. These go generally down, but you see you have your points that are kind of really far away from that, from our line we drew. So it is it's negative because it's going down. So as you're going forward, it is negative. Okay. But in this, it's going to be what we call a weak negative, and it's a weak, actually, it probably would have been better if I wrote weak first. Let me do this. So it's a weak, it's a weak association. It's a negative association because it is going down. It's going down in this. And the association is in a linear pattern. So it's a linear, we're in a line, okay? It's in a linear pattern. It's in a line going down, okay? So that association is weak, negative, and linear on that, all right? So if you then go down to number 2 on this, I would hope from the many, many like things we drawn that this is not a linear. It's not linear. This is actually called a parabola. That's a parabola. It's a parabola. Okay. That's a parabola. So that parabola right there. What's up, Malachi? So number 2 on this, there is what we call it's a non-linear, it's a non-linear association. Non-linear association. Okay? And yes, this should actually have association here too. Okay. So 1 would be a weak negative linear association, while 2 is a non-linear association. Again, it's a parabola. There. Okay. So that's that. Let's go down. So now we use those linear models or those scatter plots that we drew. Now we can make predictions based on what we call in this line that we drew is called our line of best fit. That is a line of best fit. Line of best fit. I can take this line and I can make a prediction based on the equation of that line. I can make a prediction, say if this line was to extend and extend and extend and extend and go way off your screen there. I can sit there and make predictions and solve for an unknown variable. So let's look here. This equation that you see, this equation is the is the equation for that straight line. Okay. So if we go down to number 1, it says if an employee earns, let's actually break this down real quick. The 120 that you see, so if we go back, the 120 would be our y-intercept, and then the 6 is our slope, up 6. If you were to actually go up 6 and over 1, or however you wanted to do it, the slope of the line is a positive 6. I just kind of wanted to kind of reiterate that. Right? So y equals 6x plus 120. So if an employee earns $570, what's the expected number of copiers sold? So if I start out with y equals 6x plus 120, y in this instance is going to be those wages. So if the wages are now going to be 570, 570 equals 6, we don't know the x, plus 120, I can sit here and I can solve for x. So if I subtract 120 from both sides, 120s cancel. I'm left with 6x equaling 450. And if I divide both sides by 6, what is 450 divided by 6? 450 divided by 6 should be, I believe it's 75. Make sure I do that. 450 divided by 6 is going to be 75. So x equals 75. So 75 equals x. What is x? So 75 equals x, and what is x then? X is the number of copiers sold. So x equals 75. Basically, what that's saying is, well, what at 570, and I go over, what's it going to be at? And you can see that if I were to drop that down, it's about 75. All right. So then, consequently, I didn't give you anything. It's whoever printed them out there, Kennedy. Yeah, I'm in Trumbull County. I didn't print them out. They printed them out at the school. If anything, with that, I mean, it's available on Google Classroom. Um, I don't know specifically which ones. I know they were printing them out at the school there. Um, just kind of hello again. Yes. So so if I look at this and if I say if an employee sells 100 copiers, so now 100 copiers. Let's start out again with our y equals 6x plus 120. If y equals 6, the number of copiers is now going to be 100 plus 120. Y equals 600 plus 120 because 6 times 100 is 600. Well, 600 plus 120 is 720. 720 should be what the expected wage is. Okay? That's kind of making at least somewhat sense. I know we did that a little while back, but again, that's hopefully something that's kind of at least rekindling the mind, at least somewhat there. All right, so let's get to the fun part. Let's get to the fun part right here, which is what we call about two-way frequency tables in this. So if you look at this and you say the two-way frequency table will display the relationship between paired paired categorical data. Paired categorical data. Gender and movie type. If you look at our example, or in this, you know, gender and juice. Okay, two different pairs of data on that. The two-way frequency table shows the results of a random survey about the favorite drink of boys and girls. Mr. Markham said that boys are more likely than girls to prefer milk. Is his statement true? Are boys more likely than girls to prefer milk? Well, you would think at first because it says there's 10. If you look at this and you say, well, 10 prefer milk compared with 7, but here's the problem. That's 10 out of 30 compared with 7 out of 20 on this. So when you actually do the percentages and all that kind of good stuff, it's actually not true. So, anyways, so if I look at the two-way frequency table for the practice for number 1 here, this is Mrs. Leary said that according to the data, girls are more likely than boys to watch movie A. So movie A, so all we're looking at here is movie A on this. Movie A, and whether or not boys and girls here. Okay. So that according to the data, girls are more likely than boys to watch movie A. So in this, 16 out of 55, and I'll put a G down here for girls, and then compared with 14 out of 45 boys. Now, if you remember, when we convert this, these ratios here to percentages, 16 out of 55 is 29.1. 14 out of 45 is going to be 31. So 31.1. So when we go back out of there and we say, because that statement, so that statement there that girls are more likely than boys to watch movie A is actually going to be false, because the ratio of the boys, so the ratio of the boys who chose A, if you actually compare that out, is greater than the ratio of girls. Hope that makes sense, guys. I know it's kind of backed my way into that, but because I look at it and say, well, what's the percentages? 31% of the boys liked that, while 29.1% of the girls liked that. So to go back and to say, well, what is the answer on this? Is the statement true or false? It's false. It's false. You know, and I just explained it that, talking about the ratios, dot dot dot. I put ratios dot 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 because of because of what we were just explained on there. The ratio of boys liking movie A compared with girls. There's more of a ratio of boys that like movie A compared with girls that like movie A. That's kind of the roundabout example or roundabout explanation for that. So let me get back into this here. Finally, finally. Then we talk about relative frequency tables. Okay. What I want to do is I actually want to go down to number 2. I want to go down to number 2. This table, when we talk about relative frequency, it's the ratio of a data value to the total of a row, column, or the entire data set. And it's expressed as a percent. If you go above to 4.4, that's what we were kind of talking about. That's hence the lead into this last part right here. So remember, relative frequencies was dealing with percents. Well, was dealing with percents. Okay, regular frequency tables is more just the amount of people on that. Okay, so if I look at number 2 on this, what percent of cats that are female have blue eyes? So let's look. Let's look here. So what percent of cats that are female, okay, have blue eyes? So all we're looking at is female blue, okay, female. That's all we're dealing with in this question. You don't have to deal with any of this other stuff right here, okay? It's what percent of cats that are female. So how many cats are female that are sampled? Well, 120 of the cats are female on that. 120 of the cats are female on this. How many of those cats have blue eyes? Well, 60. 60 have blue eyes on that. Okay, 60 have blue eyes. If we were to divide this out, 60 divided by 120, actually the 60 divided by 120 is 0.5. If you divide that out, 60 is 1/2 of 120, so it's 0.5. And then times our 100 will make it to be 50%. So when we look at this and we say, what percent of cats that are female have blue eyes? It's 50%. 60 out of 120 of the cats, 50%. Okay, that's everything from topic 4 with that right there. I hope and I thank you guys for dealing with all of that goodness that we've been doing here. Guys, if you have any questions, with anything going forward, just because this is my last day of live streams right here, doesn't mean I'm not available. Okay, just please reach out to me. I have my email right here in the chat. Here's my email. I'm putting 9,000 arrows going to that email right here. Okay. If you have any questions with anything, okay, I mean, just please reach out. Okay. I mean, just reach out. Please keep in touch. Okay. I'm sure. So I'm sure I'll see you guys again very soon. So, but with that specific, like I said, that specific email right there, I mean, just like I said, if you have any questions, please reach out. I mean, please reach out with those. I'll be happy to, happy to help out with anything there. Okay, whether or not whatever it is going forward here. So, I appreciate you guys. I hope you guys have I hope you guys stay safe. Please stay healthy. Okay. And I'm sure I will talk to you guys again soon. Take care, guys. See you later.